So the last few days we've been talking about logarithms and exponential functions, and today we're actually going to solve equations using logarithms and exponential functions. So we're actually going to use it to solve equations. The first thing I want to talk to you about for section 7.6 is something called the property of equality. And that basically says if you have an equation has equal signs, right? And we have the same base on both sides, well, you can basically leave off the bases and set the two exponents equal to each other. So both of these have a base of 5, so you could leave those off, and you have x equals 3, just whatever is on top. So what we want to do is get our bases to be the same. So if we get our bases to be the same, we can leave off the bases and just solve with our exponents. So look at number 1 here. We have 3 to the x power equals 9 to the x plus 3 power. We need the base to be the same. And right now we've got a 3 and a 9. But we can change the 9 to have a base of 3, can't we? What is 9 with a base of 3? Or should I say, what with a base of 3 equals 9? 3 to what power? 3 squared, right? So I can change this to say 3 to the x power equals 3 squared to the x plus 3. So all I did is I changed it where they had a 9. I changed it to the 3 squared. So now basically my two bases cancel out. And I have x left on the left-hand side. And power of a power, we multiply, right? So we got to multiply 2 times x plus 3, which means you have to distribute that. You can't just say 2x. You have to say 2 times x plus 3. So 2 times x is 2x. 2 times 3 is 6. And now it's a little bitty baby equation. So we just solve it for x. So we get our x's together. Subtract 2x on each side. That gives me negative x equals positive 6. Divide both sides by negative 1 and x equals negative 6. So there's our answer. So let's recap. To start that problem, we wanted to get our bases the same. So we changed 9 to 3 squared. And then the bases canceled out. This side equals this side. You had to distribute that. And then you just solve for x. Okay? So you want to try to get it to where the bases are the same. Number 2 is a little bit more complicated because you got a fraction. And this is the same thing as 2 to the negative 1 power, right? Y'all remember that negative exponents we put on the other part of the fraction? So 1/2 is the same thing as 2 to the negative 1 power. And 4 is the same thing as 2 to what power? 4 is the same thing as 2 to what power? 2 squared. So this way, those two have the same base. So you want to look for a base that they both could have in common. So remember, a fraction is just to a negative power, and 4 is 2 squared. So now they both have a 2. So the bases cancel. And then you just multiply your exponents. What's 2 times x?
2x.
So 2x on the left. And on the right-hand side, you have to distribute. So negative 1 times x, we change the signs and get negative x. Negative 1 times negative 3, we change the sign and we get a positive 3. Y'all get that? When you get the same bases, cancel them out, put the exponents equal to each other. But you got to distribute if you have to multiply. Now, how do I solve that for x, y'all? How do we get our x's together? How do I do that mathematically?
You subtract.
I do what? Add what? Add x to both sides. What's 2x plus x? 2 plus 1 equals 3, kindergartners. And how do I solve that for x? And what's 3 divided by 3? X equals 1. So that's that. Okay. The next one, problem 3, says 9 to the 2x equals 27 to the x minus 1. So we got to get them to be the same base. What base do you think a 9 and a 27 have in common? 3, right? 9 equals 3 to what power?
2.
Squared. So that's going to be 3 squared to the 2x equals 27 is 3 to what power? 27 equals 3 to what power? The third power. Are y'all with me how we got them both? Base 3? So now we cancel out the bases and we just work with the exponents. What's 2 times 2x? 4x. Equals, this is distributing, so 3 times x is what? 3 times x is what? Thank you. And 3 times negative 1 is? 3 times negative, I'm distributing. This times this and this times this. What's 3 times negative 1? Thank you. Y'all are like pulling teeth today. Now we got to get our x's together. How do we get our x's together? Thank you. Driving me crazy. So that gives me x equals negative 3, and it's already solved, isn't it? All right, so number 4 says 100 to the 7x plus 1 equals 1,000 to the 3x minus 2. Now, what base do y'all think they have in common? A 10. So 100 is 10 to what power? Y'all, this is like seriously a 6th grade question I'm asking you. 100 is 10 to what power? No. Squared, right? 10 squared is 100. Okay. 1,000 is 10 to what power? Oh, blowing my mind. Y'all with me? So you want to get them the same base. The bases cancel. Now you got to multiply your exponents, so you have to distribute them. So what's 2 times 7x? 14x. And then 2 times 1 is? 2. Equals, same thing on this side. What's 3 times 3x? I can just quickly, if y'all don't want to answer me and us communicate and make sure you understand, I can quickly work these problems and y'all can have a ton of questions. But I'm trying to make this a student-centered lesson. That means you're going to have to participate. I can do this lesson. Look, I did it. Y'all need to learn how to do it, so participate. 3 times 3x is what? Thank you. And 3 times negative 2 is what? Negative 6. Now I got to solve the equation for x. So I want to get my x's together. So how do I do that? Yeah. So that gives me 5x plus 2 equals negative 6. Then what do I do? Thank you. So 5x equals negative 8. Now what do I do? Divide by what? So it's x equals negative 8 over 5. And it's okay that it's a fraction, and it's okay that it's improper. Any questions about that? Y'all, this ain't bad. We've done way worse. Way worse. Well, we gonna do something different now. So y'all understand how we did that? We wanted to get the bases the same, so that way we can just work with the exponents. Well, these are exponential equations because the variables are all in the exponents, and there are no ways we can get same bases on these. There's no way I can take that 4 and 11 and make them equal bases. So what's the opposite of taking an exponent? Using a what? The word is on the screen. A logarithm. Okay. So what you want to do is you want to use the logarithm with the base of whatever your base is with the x. So we want to use a base 4 log for this one. So we're going to take log base 4 on both sides. 4 to the x equals log base 4 of 11. What you do? Because I want my log to cancel out and just leave me with x. And so remember, log base whatever cancels out if it's the same. Okay? So if I take log base whatever, if this is equal with its base, then it cancels out. So that's why I'm using log base 4. Okay? So take a log of both sides. That cancels out. And that leaves me with just x. So x equals log base 4 of 11. Now, our calculator will not calculate that, will it? What base is the log in our calculator? Base 10. So to get this to be where I can use base 10, I'm going to use that change of base formula we did yesterday. That's log of the big one over log of the base. Y'all remember that? Base goes on the bottom. Change of base formula. Change of base. So you do log, and this is base 10. So we're going to type that straight in our calculator. Give me a second while I get my calculator, please. Okay, there it is. So I'm going to type it in my calculator. Log base 10 of 11, close the parentheses, divided by log of 4 equals about 1.729, which is about 1.730, right? So I'm going to say x is approximately 1.73. Why did I use the squiggle line? I rounded, right? So what you want to do? If your x that you're solving for is in an exponent, then you take a log of whatever that base is on both sides, because equations you got to do the same thing to both sides. That should cancel out that side. And then you do change of base. Log of the big one over log of the base, and then put it in your calculator. Okay, round the decimal. All right, let's do this one. Same thing. 9 to the x power equals 35. So to solve for the exponent, I need to take a logarithm. What base am I going to use? 9, because I got to cancel out the 9. So log base 9 of 9 to the x equals log base 9 of 35. So that cancels and leaves me with x equals log base 9 of 35. So I need to do the change of base formula. What does change of base tell me to do? Log base 10 of what? 35 over log base 10 of 9. And then what do I do? Put in your calculator. Log of the big one divided by log of the base. Enter. And that rounds to about 1.618. Any questions about that?
How does he get it?
You got to solve an equation with it. Yesterday we just got that much from here to here. Today we had to start here and know how to set it up and solve it to get the x by itself. Yeah. I'm not going to be super picky on that on your test. All right, let's do one more similar, and then I'm going to have you try one on your own. But I've got it blacked out, so you can't work it ahead of time. Now, this one is just slightly different, and I'll show you what to do with that in just a second. I've already had that conversation with you. All right, so how do I get rid of the exponent? I take a what? Logarithm. Of what base? What base has the x in it? What base has the x? 7. So I take log base 7 on both sides. So whatever your base is that has the exponent in it, that's the base you need to take of your logarithm. So log base 7 of 7 cancels out. That leaves you 9x equals log base 7 of 15. So, x, I divide both sides by 9, don't I? So log base 7 of 15 divided by 9 will get us our answer. But log base 7 of 15, got to change the base, don't I? Log 15 divided by log 7, and then divide it by 9. Okay? Y'all see that? So we're going to have to do that in our calculator. We're going to do log 15 divided by log 7. Hit enter, and you got a decimal in there. So y'all go ahead and do that and get that decimal, 1.39166, blah, blah, blah.
Then you divide that by 9.
And then if you just hit divided by, don't clear it or anything, just hit divided by. See how it says the word A and S for answer? That means it stores the previous answer. So that means it takes that answer right above it, and then we divide it by 9. And that divides everything by 9. So my x is approximately 0.155. Any questions? So you guys are going to try this one, which isn't that bad. It's actually probably the easiest one we've done of those. Take a logarithm on both sides, solve it for x with your calculator. No, this is your class you're assigned to. You're going to be in this class. You just need to watch it. Be quiet. I'll ask you to be quiet and respectful.
I do respect.
You're not being honest. Being on your phone when I'm up here teaching is not being respectful. Just be quiet. All right, so what did you do first on both sides, y'all? Take a logarithm of what base? 2. Okay, then what happened? Cancel that out. So x equals log base 2 of 5. So x equals log base 10 of 5 over log base 10 of 2, right? So it's always big divided by the base. Base always goes on the bottom. So y'all type that in. Log 5 divided by log 2. What'd y'all get for your decimal before I hit enter?
2.3.
There you go. So that's about 2.322. What did I say? 322. 2.322. I got it mixed up. All right. Next thing we're going to talk about. So that was when we took a log of both sides. So what if there is a log in the original problem? So we're going to start with them like this when there's already a log on both sides. So if there's already a log on both sides and they have the same base, guess what you can do? Well, you can cancel those babies out. So if you have the same log on both sides, you can cancel them out. Now it's a little simple Algebra 1 equation. 4x minus 7 equals x plus 5. And then you just get your x's together. And how are we going to get those x's together? Subtract x on each side. It's 4x minus x. Minus 7 equals 5. Then we add 7 to both sides. 3x equals 12. Divide by 3 and x equals what? That's it. So if the log is the same on both sides, you just cancel them out. And then just set the two things in parentheses equal to each other and solve for x. Those are really simple. Let's do another one. If you can't read this over here, it says 6x minus 12. So log base 4s are on both sides, so what happens to them? You can cancel them both out, so you're just left with 2x plus 8 equals 6x minus 12. Get your x's together. 8 equals 4x minus 12. Add your 12 on both sides. What's 8 plus 12? Divide by 4. What's 20 divided by 4? Those are easy, right? Okay. So what if you don't have a log on both sides? You just have it on one side. What's the opposite of a logarithm? Exponent, right? Logarithms and exponents are inverses of each other. They cancel out each other. So if they give us a log on one side and not both sides, we have to do something called exponentiate both sides. Say that word, exponentiate. That means put it in an exponent. Okay, exponentiate means put it in an exponent. And you're going to use, the base you're going to use is going to be the base of the log. So I have a log base 4 over here, so I'm going to give everything a base of 4. All that's in the exponent. Power. So both sides get a base of 4. That's called exponentiating the equation. Now what happens right here? Those cancel out. So that just leaves you the 5x minus 1 equals, what is 4 to the third power? 64. Your blue sheet tells you that. Your rooftop button tells you that on your calculator. And then you solve that for x. So how do we solve that for x?
Plus 1.
Add 1 to both sides. So 5x equals 5. And x equals, whoops, my 30 looks crazy. I'm trying to fix it. There we go. So those aren't bad either. So if they give you a logarithm on one side, to get rid of it, you exponentiate both sides. You take whatever the base is and give everything that base. Same thing with this one. Log base 7 of 3x minus 2 equals 2. The log's only on one side, so how do I get rid of the log? Give everything a base of what? So we exponentiate both sides, giving everything a base of 7. So put everything in the exponent. So 7 log 7 does what? Cancels out. So then 3x minus 2 equals what? What's 7 squared? 49. How do I solve that for x? Add 2. So 3x equals, and then I divide by 3, and x equals 17. Okay. So all of our logs have been regular logarithms. The last thing I want to talk to you about is natural logs and base e. I know I looked at your study guide a while ago in your test, and it does have some with base e, so I want to make sure you see some. So the opposite of an e is a natural log, and the opposite of a natural log is an e, right? Remember, the e is that number 2.17 number. It's irrational like pi is. So we have a natural log, that's what ln, on the left. So how do I get rid of a log? I put it in a exponent, right? Which means exponentiate both sides. Some people say you eat. You don't eat it, you eat it. So that means you give everything a base e on both sides. So the e and the natural log cancel out. They're opposites of each other, or inverses of each other, I should say. And then that's x plus 2 equals e squared. E's just a number. We're going to put that in our calculator for in a second. How do I get rid of the plus 2 with the x, though? Subtract 2. So x is going to equal e squared minus 2. And we can put that in our calculator to approximate it. Y'all remember how to get e on your calculator? That's a ln, but yeah. You hit second ln, and then hit a square, and then hit minus 2. Oh, it's up off the screen. Sorry. There you go.
We plug that in one more bit.
Yeah, I'll start over. You hit second ln. Oops. I made mine disappear. Second ln. Put your 2 in there for your square. Close your parentheses, and then hit minus 2. And then hit enter. And it gives you a decimal. And you round it a couple of spaces, so about 5.389. Okay. So that's what you do if they give you a natural log in the equation. You exponentiate both sides with an e. Well, what if they give you an e on the one side of the equation? What's the opposite of an e? Taking a what?
Power.
Taking a natural log. Very good. So that means you LN both sides, right? And LN E right there cancels each other out. So that's just 2x equals the natural log of 5. And how do I get rid of the, how do I get the x by itself? Divide by 2. And so you can just type that straight in your calculator and round it. LN 5. And then you can just hit divided by 2 all at once and hit enter. And that's going to be x is approximately 0.805. Is that okay with everybody? All right. So that is the end of what we're going to do in section 7.6. And that's also the last thing we're going to do in chapter 7 altogether.